Just 80 more Jupiters to our largest planet, and our solar system would gain a second sun. Jupiter is already more massive than every other planet in our solar system combined, and still not enough. Scientists call it a failed star, a planet that came achingly close to becoming something else entirely. If Jupiter ever ignited, Earth would suddenly find itself orbiting inside a chaotic binary star system. What would it actually take to turn Jupiter into a star? And could our world even survive it? Every star in the universe begins the same way, as a cloud of gas collapsing under its own gravity. More mass means more gravity, and more gravity means a hotter, denser, more violent core. Once that core reaches about 10 million degrees Kelvin, hydrogen atoms can finally begin fusing together. That fusion releases enormous energy, and a dead clump of gas suddenly becomes a living, burning star. Jupiter currently sits at just 0.1% of the mass needed to become our sun. To become a true sun-like star, Jupiter would need roughly 1,000 times its current mass. But to become a cooler, dimmer red dwarf, it would only need about 80 Jupiter masses added.
That still means adding roughly 25,000 Earths worth of extra material onto the planet. Before hydrogen fusion, there is an earlier threshold, a strange and lesser-known object called a brown dwarf. At just 13 Jupiter masses, deuterium fusion could ignite, without yet making Jupiter a true star. Astronomers have actually found a real star barely larger than Jupiter, proving how close this boundary truly is.
That star, EBLM J0555-57Ab, sits about 85 Jupiter masses, the smallest confirmed hydrogen-fusing star known. Red dwarfs like this one are actually the most common stars in the entire Milky Way galaxy. About 3 out of every 4 stars near our sun are actually faint, cool red dwarfs. Proxima Centauri, our closest stellar neighbor, is itself a small, dim, long-lived red dwarf star. So, a Jupiter-turned star would not be unusual in the galaxy, just catastrophic for our own solar system. Adding that much mass could not happen naturally. It would require an almost impossible cosmic coincidence. Perhaps a rogue planet or a passing brown dwarf could theoretically merge with Jupiter over millions of years. For this thought experiment, imagine the mass simply appears and Jupiter suddenly crosses the fusion threshold. The ignition would not be silent. It would release a burst of radiation and gravitational disruption instantly. Within moments, our solar system would transform from a single star system into a true binary star system. Binary star systems are actually common in the galaxy. Roughly half of all sun-like stars have a companion. But our solar system's planets evolved for 4.6 billion years around only a single gravitational anchor.
Suddenly adding a second massive gravitational source would violently disrupt every single orbit in the system. Jupiter's moons, dozens of them, would be the very first casualties of this sudden transformation. Some moons would be swallowed into the new star, others hurled into deep interstellar space forever. Saturn, Uranus, and Neptune would feel the gravitational shockwaves within just a few short years.
Their orbits could stretch, tilt, or even eject them entirely from the solar system within millennia. Meanwhile, the inner planets, including Earth, would face an entirely different and far more immediate danger. A new red dwarf, even a dim one, would flood the inner solar system with fresh radiation. Earth's climate, perfectly tuned to a single sun's output, would be thrown into violent imbalance immediately.
Even a faint red dwarf adds real heat, and 2 suns means constantly shifting, unpredictable temperature swings.
Ocean currents and jet streams, both driven by consistent solar heating, would spiral into complete chaos. Day and night themselves would lose their familiar rhythm, with a second sun rising at unpredictable times. Earth's own orbit could slowly become unstable, pulled unevenly between our sun and this brand new star.
Over centuries, this gravitational tug-of-war could send Earth spiraling toward one star or flung into darkness. Mars and Venus, our closest planetary neighbors, would suffer the same violent orbital disruption simultaneously. The asteroid belt between Mars and Jupiter would be violently scattered by the sudden new gravitational force. Some of that scattered debris could be redirected onto entirely new collision courses toward the inner planets.
A sudden increase in impact events could rain down on Earth for thousands of years afterward. Even Jupiter's iconic Great Red Spot, a storm centuries old, would likely be torn apart instantly. Jupiter's powerful magnetic field, already the strongest in the solar system, would intensify dramatically during ignition. This new stellar magnetic field could generate massive flares, unleashing intense radiation across the solar system.
Red dwarf stars, despite their small size, are actually notorious for extremely violent stellar flare activity. Astronomers studying real red dwarfs have recorded flares thousands of times stronger than our sun's largest eruptions. If Jupiter behaved this way, Earth's atmosphere could be bombarded by unprecedented waves of radiation. This radiation could strip away atmospheric layers and disrupt satellite systems and electrical infrastructure worldwide.
Some scientists studying exoplanets around real red dwarfs question whether life could even survive such harsh conditions. Yet other researchers argue red dwarf systems could still support life if planets orbit at the right distance. This scientific debate remains unresolved, and Earth's fate in this scenario would depend entirely on distance. Here is the biggest twist. A new red dwarf sun would actually be surprisingly dim in our sky.
Despite having 80 times Jupiter's mass, a red dwarf shines with only a tiny fraction of our sun's brightness. From Earth, this new star might appear only slightly brighter than Jupiter does in our night sky today. The real danger was never its light. It was always the sudden, violent shift in gravity itself. Gravity, not light, is what would truly rewrite the orbits of every planet in our solar system.
This is why astronomers say mass, not brightness, determines whether a system remains stable or collapses. Computer simulations of similar binary transformations suggest total solar system stability could take millions of years to settle. During that chaotic settling period, entire planets could be lost, merged, or ejected from the system permanently. Some astronomers believe Earth's survival would ultimately come down to pure gravitational luck, nothing more.
This thought experiment reveals something remarkable. Our entire solar system's stability depends on a single dominant sun. Astronomers studying real binary star systems have found many where planets simply could not form stably at all. Yet other binary systems have surprised scientists by hosting stable planets orbiting both stars simultaneously. This means our solar system's fate in this scenario is genuinely uncertain, not simply guaranteed destruction.
What remains certain is that nothing about our solar system would ever look or feel the same again. Thankfully, Jupiter gaining 80 times its mass naturally is considered essentially impossible within our solar system's lifetime. Jupiter already claimed nearly all available material in the early solar system, leaving little left to gain. This scenario remains a powerful thought experiment, not a genuine threat facing Earth's actual future. Yet real binary star systems like this exist across the galaxy, shaping entirely different possible worlds.
Studying this impossible scenario actually helps scientists understand what makes our own solar system so rare. Somewhere out there, a planet like Jupiter did cross that threshold and became a sun of its own.